Hey, this is Miss Park, and this video is about the procedure of completing the square. Now I'm going to present it in a slightly different way than you may have learned last year. I'm going to use area models, which you may recall from an earlier video on expanding and factoring. So I'm upside down. Let me turn this. Okay, so why do we even complete the square? So if we take an equation of a quadratic function, this is standard form. Okay, standard form is kind of useless. It really doesn't tell us a whole lot about it. We have much better forms than standard form. So a nicer form is vertex form. And vertex form looks like this. And from vertex form, we can read the vertex, right? The vertex is HK. And this is useful because if we're asked to solve a maximum or minimum problem, so what is the maximum profit, or what is the maximum area, or what is the minimum cost, or any of those things, we have to know where the parabola sits and how high it goes or how low it goes. So from here, from the standard form, is very hard to tell. From the vertex form, if I know the vertex, then I can use the vertex to start sketching the parabola, and I can tell here's my vertex, and I can tell easily what my maximum value is, okay, or minimum value. And I can also tell where that value occurs. All right, so that's why we even bother converting forms. Okay, so completing the square, it's called that because you'll see that this equation has just a bunch of terms, but this equation has a binomial squared. All right, and why we're completing it is what you're about to see. I'm going to show you with the area models. So I'm just going to remind you that when we expand things, I'm just going to go x plus 3 squared. Okay, so binomial squared. When we expand this with an area model, I'm going to get a rectangle where the dimensions are both x plus 3, like this. And then I fill in the areas of each individual rectangle. And so this is a 3 by 3, which is a 9. Okay, and that's how I would expand it. And something I would notice is that notice these two, they're the same, right? And of course they're going to be the same because these two numbers were the same. All right, going backwards, it's the exact same principle. All right, so let's say, for example, I have y equals x squared plus 10x plus 8. Okay, and I want to convert this into vertex form. Right now, it's not, right? But I'm going to need some kind of binomial squared, and then there'll be stuff left over. All right, so let's start with the x squared plus 10x, and let me see if I can factor that. All right, so I want x squared plus 10x. So I know my x squared will sit here, so this is x and x. And now I want the 10x to be the sum of these two boxes, right? But because I want this binomial to be squared, these two numbers have to be the same. So therefore, these two numbers have to be the same. So if I have to pick a number that, 2 of it gives me the 10x, it has to be a 5. So this has to be a 5, and this has to be a 5. And here I'll get 5x and 5x. And this is where I'm going to get the two numbers that are the same. Okay, so now I have my x squared plus 10x. The problem is I have to still fill in this last box. Now this last box is a 25. So x squared plus 10x plus 25 is a perfect square, but that's not my question. My question is 8, as an 8, not a 25. So in here, I actually have too much, right? I have too much. I should have 8 in this box, but I actually have 25. How much too much do I have? So I'll go 25 minus 8. What's the difference? Is 17. So I know that this equation, or this expression, x squared plus 10x plus 8, is equal to x plus 5 squared, which was everything that's in here, but it's too much. So I have to subtract 17. All right? If I expand this, I'll get a plus 25, and then here's my minus 17. I get my original question. And from this, I can see that the vertex is -5, -17. Okay, so that's completing the square with the area model. let me take you one further. Okay, suppose I had an a value, because right now I gave you a simple one where the a value is just 1. So suppose I had an a value, 2x squared plus, let's go, I had it written up here. Okay, 2x squared plus 4x plus 3. Okay, so there's an a value. I'm going to do the exact same thing that I did up here, but I'm going to get rid of this 2 so that I can just have a plain old x squared in this corner. I will factor the 2 out of the entire thing. Okay, so I factored the 2 out. And now this part in here is what I'm working with in my rectangle. I want x squared plus 2x. These two have to be the same because I'm going to want a perfect square here. So if I'm going to want these two to add up to 2x and they have to be the same, that means they each have to be x. So my dimensions are x and x here. This has to be a 1 and this has to be a 1. So far I have my x squared plus 2x, but I have to also fill in this. So this is 1 times 1. I'm trying to get to 3 over 2, right? I only have 1. 3 over 2 is actually bigger than 1. So I actually have here not enough. How much do I have to add to this to get to the 3 over 2? So let's see. I already have 1. I have to get to 3 over 2. What's the difference? Is a half. So I need to add a half to this to get my original question. And remember, I'm sort of leaving out the 2 for now. We'll deal with the 2 later. We're just going to deal with the completing the square of the inside. So what I really have here is I have this part here is x plus 1 squared, which is the stuff in the square here, but I also have to add to it a half in order to make it equal to here, because it wasn't enough. There was only 1. And this whole thing is times 2. And now I can multiply the 2 back in. And I've got my vertex form. And my vertex is -1, 1. Okay, and that's how you complete the square with area model. I'm just going to run through how were you taught last year to complete the square with just algebra and no area model. So last year you were told this, and you are perfectly welcome to use this method. Okay, 2x squared plus 4x plus 3. Actually, yeah. Okay, 2x squared plus 4x plus 3. What you were told last year is see these two terms. Let's take out the 2. Let's take out the coefficient of the x squared from just these 2 terms. And the plus 3 will hang on the outside. Okay, and now inside, I want to make this thing a perfect square. I want to complete this square. It means I have x squared and an x and an x. So far, that's good. But to complete the square, I must add this 1. So that I'll have a 1. So last year you were told, what should I add? Well, I'll take that middle number, which is the b, and then I'll divide that by 2, and then take that value and square it. So the middle number is 2, divided by 2 is 1. Take that number and square it, you get plus 1. And then we were told there's a problem. We cannot just change the question and just add a 1 from the sky. There is no 1, right? But so if we're going to put it there, we have to take it away right away so that it's as if we didn't put it there. So it's as if I added a 0, right? Now it's equal to the line above it. So this was the procedure last year. And then the x squared plus 2x plus 1 can be written as a perfect square. So I'm just going to collect all of those. And then here's your -1. And there's a plus 3. And now I'll just distribute this 2 into everything. So this is 2 times x plus 1 squared minus 2 plus 3. Collect the like terms on the end there, plus 1. And your vertex is negative 1, 1. Okay, same thing. Perfect, right? Either one. You can use this method or you can use this method with the area models, whatever makes more sense to you. This method where we have to take half, just kind of remember the process of taking half the b and then squaring it, just so you know, that's not just a trick, okay? That is coming from the area models. Remember what we did to split up the 2x into 2 equal parts, right? We took the 2 and divided it in half, and we got 1 and 1. So that's where that part's coming from. And where's the squared coming from? That's this number over here. What number do I have to add into x squared plus 2x in order to make a perfect square, so in order to fill in this whole rectangle? So that's where that all came from. So this is completing the square, converting to vertex form, and you may use any method that you like. Okay, thank you for watching.